Welcome to lesson number 6, which is on dividing polynomials. There's going to be 3 different topics in this lesson that we're going to talk about. First one that we come across is dividing a polynomial by a monomial. And it's going to be pretty simple to do. What we're going to do is we're going to rewrite each term in the numerator written over the denominator individually with the signs in between, and then we're going to simplify. Okay, so here we have an example. I have a polynomial on top being divided by a monomial on bottom. So all I'm going to do is I'm going to rewrite this. My first term is 9x squared y. I'm going to write that over 3xy. My second term is a negative, so I'm going to do minus 15xy squared written over 3xy, and my last term is plus 21y written over 3xy. Okay, so that was the first step. Rewrite each term. Next, I'm going to start to simplify, and we need to know some of our power rules as far as exponents go, so hopefully you remember some of these from Algebra 2. Okay, when I start simplifying here, I end up with 3. Here, I lose an x, and I lose a power of x, and last, my y's cancel. So what I'm left with on top is just 3x. My second term, my 3 and 15 will reduce down to 5. My x's completely eliminate, and I have 1y on bottom, which will eliminate 1y from the top. So what I'm left with here is negative 5y. Last one, my 3 and my 21 will reduce to a 7. I don't have any x's, so I'm going to end up having an x staying on bottom. My y's, those cancel out. So what I have left here is I have a 7 on top and an x on bottom, so plus 7 over x. That is my simplified expression. Okay, so here's a problem for you to try. Pause the video and resume it when you're ready to check your answer. Alright, let's check out how you did with this. We're going to start by rewriting each term. So that's my first term with the signs in the middle. So here we have 18c df over 6c squared df. Last, minus 12c squared d squared f squared. Okay, so we've taken our first step, rewrote each of those over the denominator. Now I'm going to start simplifying. My 6 and my 36, that reduces. I have 2 c's on bottom. I can get rid of 2 from the top, so I'm left with just 1. My d's are going to cancel completely, and 1 f from the bottom, take away 1 from the top. I'm left with 6cf for that first term. Second, my 6 and my 18, that reduces to 3. I have only 1 c on top, and I have 2 on bottom, so I'm going to remove the 1 from on top, and I'm going to leave 1 on bottom. That means I'm going to have 2 terms, 1 on top, 1 on bottom. I can see that my d's and my f's are all going to cancel, so I'm left with plus 3 over c for my middle term. Last, my 6 and my 12's, those reduce. I can see I've got c squared, so those are going to cancel each other out. 1d on bottom gets rid of 1 from the top. Same thing with my f's. I have 1 on bottom, 1 and 2 on top, so I can take 1 away from the top. What I'm left with here is minus 2df. Okay, hopefully you came up with the same solution for that one. Dividing polynomials by a monomial, not really too bad, right? Just break it up, work with it piece by piece. Polynomial long division, a little bit more involved. Okay, this is our second topic that we're going to be talking about. Now, there's 2 ways of actually doing this type of division, where we have now a polynomial divided by a polynomial. Okay, and you'll see it over here as well, polynomial, polynomial. Okay, so we're not going to work with breaking it up piece by piece. Instead, we're going to work with first polynomial long division. How that's going to work, it's going to be set up pretty much like regular long division, right? You're going to take whatever your dividend is, it's going to go inside the little box area. Your divisor is going to go outside. Okay, so that's how we're going to set it up. Right, we have x minus 5 on the outside, 3x to the third minus 17x squared plus 15x minus 25. That's all inside. Now, real quick, if you have any spaces, right? I have third power, second power, first power, no power. If I was missing a term, I'd want to have to fill it in with a 0 placeholder. And I want to make sure that I have these listed in standard form, meaning highest power, and then it's going to go down. Okay, so we want to make sure it's in standard form with 0 placeholders. Now that I have that, what I'm looking to do is I'm looking for a coefficient and an x to a certain power that when I multiply this x here, it ends up being the exact same as this term inside. So what am I going to have to do? Well, I have a 1 in front, so I need to multiply by 3 so that I get that 1 to become a 3. And right now I have x to the first power, so I need to multiply by x to the second power. When I do that, that gives me now 3x to the third, right? Because first power, second, they add to the third. But I also need to distribute to this first term. What I have here is 3 times negative 5, which is negative 15. And then I have x squared, which is also multiplying. Okay. Now, the thing that people forget, hopefully you will not forget this. Okay, we now need to multiply this whole red expression by negative 1. Basically, change the signs. So I'm going to change the sign here. I'm going to change the sign here. If you don't do that, you're going to mess this up. So please make sure that you change your signs. Okay, now I'm going to combine. I'm going to add straight down. These eliminated, which we wanted to do. That was the whole reason for picking these numbers up here. Here I have negative 17 and positive 15. When I combine those, I get negative 2x squared. I now need to drop down my next term. That's this plus 15x. And I'm going to repeat that process. Okay. What I'm looking for now is to change this x into a negative 2x squared. Okay. So in order to get positive become negative, I need to multiply by a negative. That 1 I'm going to multiply by a 2. And if I have x to the first, that means I need another x to the first. That'll get me that x to the second that I want. Okay, then I'm going to start doing my multiplication, right? That gives me the negative 2x squared that I was hoping for. And when I distribute to my first term, negative 2 times negative 5 is positive 10, and then times x. What are we going to remember to do? Change the signs. Right? So if I change signs here, that becomes positive, and change signs here, I now have a negative, and we're going to combine. Right? Those eliminated, which is what I was hoping for, 15 and negative 10, that's 5. I'm going to drop down my final term. Okay, and I'm going to ask that question one last time. How do I make x become 5x? I'm going to multiply by positive 5. Okay, so 5 times x, that gave me my 5x. 5 times negative 5, that gives me negative 25. And one more time, we have to change the signs. So that becomes negative, that becomes positive. When I add, my 5's eliminate, negative 25 and positive 25, I get 0. Now, that's my very last term, right? There's nothing else getting dropped down with it. If I notice that I have a 0, that means I have no remainder. And this is my factored, or my divided polynomial. Okay, that's the solution that we're looking for. If this number was not a 0, which we'll see in the next example, we're going to add whatever this is divided by our original divider. And you'll see that in this example here. Okay, so notice in this problem, right, I have x to the fourth, I have no x to the third, it jumps down right to the second, I have no x to the first either. So I need the 0 placeholders that I was talking about. Here I have to the second, to the first, and no power. So I don't need any 0 placeholders here. So this is my divider. It's going to go outside the box. This is my dividend. It's going inside. X to the fourth. I need a 0 placeholder for the third. So 0x to the third. I have 3x squared. I had also mentioned I need a 0 x to the first placeholder, and then plus 1. Okay. Process is the same. I need to make this x squared become an x to the fourth. So I'm going to multiply by x to the second. This time, when I distribute, it's going to go to all 3 terms. And then we're going to write all 3 terms underneath as well. Okay, so we have x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. Right, 1 and 2 is 3. Here, x squared times 3 is 3x squared. A very important step of changing your signs. That becomes negative, that becomes positive, that becomes negative. This eliminated as we had hoped. This is going to give us 2x to the third, and those ended up giving us 0x squared when we added, and I'm going to drop down my next term. Okay, we need these 0 placeholders, so don't skip them. We need them. Okay, we now need to make this x squared look like 2x to the third. So we want to multiply by 2 and by x. That'll get that to become to the third. 2x to the third. Now we multiply here. 2 times negative 2 is negative 4x to the second power. And here, 2 times 3 is 6x. Changing signs. Change, change, change. Okay, that eliminates. We get 4x squared here. 0 minus 6 would be minus 6x. And we're going to drop down the plus 1. So we got one more step, it looks like, left. I need to make this x squared become 4x squared. So I'm going to multiply by 4. So 4 times x squared is 4x squared. 4 times negative 2 is negative 8x. And 4 times 3, that gives us 12. Change the signs all the way through. That goes away. Here we've got, let's see, 2x, and here we've got minus 11. How we're going to write this now? Because remember, I said before, we had a 0 over here, that's a remainder. We didn't write it. Here we have a remainder. So how we're going to write this? Well, here's the first part of my solution, right? I have x squared plus 2x plus 4. This happens to be positive, so I'm going to say plus, and whatever that happens to be is going to go on top, so 2x minus 11. What I'm going to put on bottom is my original divisor, x squared minus 2x plus 3. Okay, so there's a couple examples for you to try. Okay, pause the video and resume it when you're ready to check your work. Alright, let's check out how you did with these two problems. Okay, first we want to set it up in the correct setup. X plus 3. Inside's going to be 2x squared plus 10x plus 12. We're going to multiply by 2x. That'll give us 2x squared plus 6x. Change the signs. So let's see, 4x. Drop that 12 down. Now we need the x to become 4x, so we're going to multiply by 4. So 4 times x is 4x. 4 times 3 is 12. We're going to change all those signs. That goes away. We have a remainder of 0. So that must be our answer right up here. 2x plus 4. Hopefully you got that one. That was an easy one. Here, not as easy, right? I have x to the third, x squared, x to the first, no power. So this one's fine. We have everything we need. But here I notice that I've got 2x squared and I'm missing x to the first. Hopefully you observe that too. Right, so we're going to need that 0 placeholder. 2x squared plus 0x plus 1. That's what's on the outside. 6x to the third plus 10x squared plus x plus 8. That's all on the inside. Okay, to make 2 become a 6, we're going to multiply by 3. And to make 2 of a power become 3, it's going to multiply by 1x. So here we have 6x to the third. I multiply times 0, that's going to give me 0x squared. And if I do 3 times 1, that gives us 3x. Go through, change all the signs. My 6 is eliminated. 10 minus 0, that's 10x squared. X minus 3, that's minus 2x. Now let's bring down that 8. Now I need my 2x squared to look like 10x squared. So I need to make 2 times 5. And I don't need any kind of x's because we've already got the power that we need. So here we have 10x squared. 5 times 0 is 0x. 5 times 1 is 5. Go through, change all of the signs. That's gone. Negative 2 minus 0 would be negative 2x. And then 8 minus 5, that's 3. So our final answer, because it's the remainder, we have 3x plus 5 minus this whole thing, 2x plus 3, over our original divisor, 2x squared plus 1. We didn't need the 0 placeholder in our solution. If you put it there, it doesn't really matter. Okay, that's the solution that we were hoping for. Hopefully you got both of those correct on your own. That's long division. Then we have another version of doing this, synthetic division. Some people like synthetic division a lot better. I've grown to like it now that I've learned how to do it a little bit better. When I was in college, we had a teacher who told us to use it, and no one knew what it was. So I kind of wish that I had seen this before I got to my college class. But here it is. Here are your steps. Synthetic division. Fair warning, they're not going to make sense really until you start doing the synthetic division out. So take a moment to write these down, and then we'll start doing some problems. Okay. So step 1, it says write the coefficient of the dividend, the coefficients of the dividend, and we want to make sure that they're in standard form. And we're going to write the constant term. The constant happens to be whatever is attached to our x or whatever it is here. Okay, and we're going to write it in the box. That'll make more sense. In a moment, we'll drop down the first term. Okay, so let's look at how that looks here. First of all, with synthetic division, you have a little bit of a setup. You have this thing up here, which we call the box. we have a line down here, and then I like to put down a second line right over here, and that's going to be my remainder area. Okay, and how we're going to set this up, they said that we want to, let's see, use the opposite sign of the constant term. So here's my constant term, that plus 2. I'm going to put the opposite sign inside of my box, so minus 2. And the rest of this says, write the coefficients of the dividends. So right here, I want to make sure that they're in standard form. So I want my first power first and just the coefficient. So 4 is going to go first. My next highest power would be 8x squared. So I want just the 8 here. Then I want x to the power of 1. Right here we have negative 9. And last, I have no x on that negative 18. That's going to go right here. I'm also writing it right above my remainder box. Okay? So that was all step 1, right? We just took all this information and we set it up into the synthetic division setup. Second step, actually, I'm sorry, there's a little bit more. It says drop down the first term. So here's our first term, right? We're dropping down the 4. Second step says multiply that first term, that'd be the 4, by the r value. That's number in the box now. So the r value is negative 2 here. So what we're doing is we're multiplying negative 2 times 4. And we're going to write the result underneath the second term. So negative 2 times 4, that gives us negative 8. Step 3, add straight down. So here's what we're adding. Right here, 8 and negative 8. That gives us 0. Step 4 says to just keep on repeating these steps 2 and 3. So I would take my r value and I'm going to multiply by the next term that we got, which was 0. 2 times 0 is 0, and I'm going to write that right underneath the next term. Step 3 would be add straight down. So negative 9 plus 0, that's negative 9. And then repeat again until we've done this with all of our terms. Okay, so negative 2 now times 9, I'm sorry, negative 9. Double negatives gives us positive 18. When we combine with our addition, we get 0. Now, I have this little remainder area, right? That's our remainder. I have 0. So we're not going to be adding anything to our solutions like the last one. We're just going to write down whatever we would be getting here. That's where the end of this comes in, right? It says write the results with the variables 1 degree less than the original. So here I had x to the third. I want the variable now to be x to the second because it's 1 degree less. And I'm going to attach it to that 4. So I have 4 x to the second. I would be adding 0x to the first, which I'm not going to even write. And then I would be subtracting 9 x to the 0 power, which we won't even write. And then I would be adding my remainder, which I don't have to add. So this is really the end of my problem. Okay, so here's one for you to try out on your own. Remember, you want to make sure that this is written in standard form when you do this. Alright, let's check out how you did here. Okay, we're going to put in the box the opposite here. So we want negative 2. Writing this in standard form, I have a 1 coefficient on the fourth, I have a 5 on the third power, I have a 6, I have, let's see, that'd be 2, I have a negative 1 on the first power, and I have a negative 2 on my constant term. Set up my synthetic division little setup here, drop down my first term. That's all just step 1, the setup. Step 2, multiply. Negative 2 times 1 is negative 2. And then we're going to add straight down. I'm going to stop switching colors now. Hopefully we get the point of the process. Okay, negative 2 now times 3. that gives us -6. We add straight down, we get 0. -2 times 0, that's 0. Add straight down, we get -1. And then we got one more to go. -2 times -1, that gives us +2. Add straight down, we get 0. So hopefully we got all of these numbers. What we want to do next, we had x to the 4th. This is going to drop down a degree to x to the 1st. I'm not going to write the 1 because we don't usually write a 1 as a coefficient. I now have plus 3x squared. I'm adding 0 x's and I'm subtracting 1. There you go. That's your solution to that synthetic division problem. All right, a couple more to go. Okay, this problem here, same idea, synthetic division. Okay, we're going to set it up. Here we have -4, so we want inside of our box to be +4. I gotta make sure that I write these down in order. So that's x to the 3rd has a power of 1, x squared has a power of 5, x has -32, and our constant is -7. Drop down our first term. Okay, so that's just a setup. That's all from step 1. Then we multiply. 4 times 1, that gives us 4. Add them straight down, we get 9. 4 times 9, that's 36. Add straight down, we get 4. 4 times 4 is 16. -7 and 16, that gives us 9. Well, now we have a remainder in our little remainder area. So all we're going to do is the same thing that we did with the long division. This is positive, so we're going to add it to our original divisor. Right? So if we had x to the 3rd, this drops down to x squared plus 9x plus 4. That takes care of this stuff. And then we're going to add 9 over x minus 4. That's all you have to do when you get a remainder. So you have an example right here you can try. Pause the video and resume when you're ready to check your solution. Alright, let's see how you did with this. We want opposite, so we want +5. Here we have p to the 1st would be 1, p to the 2nd is -10, p would be 20, and our constant 26. Five times 1 gives us 5. Add straight down, we get -5. 5 times -5 is -25. Add straight down, we get -5. 5 times -5 is -25. Add straight down, we get 1. Okay, no big deal. We have a p to the 3, so that drops down to p squared minus 5p minus 5, and all we're going to do with that remainder is add it and over our original divisor, so over p minus 5. That's our solution here. Synthetic division is kind of nice, pretty quick. But we have a problem with synthetic division, and it's when we have a number in front of our x. That doesn't work with synthetic division, right? All the ones that we've seen before, it's just been plain old x. So what do? Well, we divide everything by that number. And yeah, you're going to get fractions. But I like fractions. I think they're easier to work with. So hopefully that won't be a big deal to you. Okay, what we're going to start off doing is dividing everything here by 2. If it reduces, we will. 3 over 2 doesn't reduce. I'm going to leave that alone. 2 over 2, that reduces. 17 over 2 does not reduce. 38 over 2, that reduces to 19. Okay, and now we can start setting it up like usual. What number is going to go inside of our box? Well, we want the opposite of this, so we want negative 3 over 2. Here we got rid of our 2. That's going to be a 1. Here we have negative 17 over 2. And last we have negative 19. I'm going to drop down the first term. And we're going to go just like usual now. Okay, we have negative 3 over 2 times 1. That's going to be negative 3 over 2. No big deal there. We need to add. Alright, well, when we add, my denominator stays the same. I'm going to combine my numerators. So negative 17 and negative 3, that's negative 20. Real quick, that reduces to negative 10. Okay. Let's see. Negative 3 halves times negative 10. That's going to be positive 15. Half of 10 is 5 times 3 is 15. In case you needed that. Then we add straight down. Negative 19 and positive 15. That's minus 4. Okay. Well, what we started with was x to the second. This is going to drop down a power, so it's going to be x to the first. So x. And then we have minus 10. And we're going to do minus 4 over our original. So here's the problem, right? This is divided by 2, so we've got to adjust that here. So we're going to have to multiply by 2. That gives us negative 8. That allows us to use our original. So instead of this being 4 here, we want this to be an 8. And now we can use our original divisor, which is 2x plus 3. So x minus 10 minus 8 over 2x plus 3 is our solution. Okay, so you have a problem to try on your own. You're going to end up having a same situation in the end where we had to multiply by whatever that happened to have been. That's just because we have to undo that in the end. If we did it to begin with, we have to undo it. Okay, so I want you to try this one on your own. Pause the video and resume it when you're ready to check your solutions. Alright, hopefully you remembered. We've got to divide everything by 2 to begin with. If it reduces, which here it does not, we'll leave it alone. If it does reduce, we will. That doesn't work. That doesn't work either. Okay, so we've reduced as far as we could. What's going into the box? We want it to be the opposite of this. So we want positive 7 over 2. As far as my coefficients, I have a 1 that came up first. I have 7 over 2 and negative 39 over 2. Okay, dropping down my first term. 7 over 2 times 1 is 7 over 2. When I add those, 7 and 7 gives me 14. That really reduces to just plain old 7. 7 over 2 times 7, that's going to give us 49 over 2. When we add negative 39 and positive 49, that's 10 over 2, which reduces to 5. Now, we don't want the 5 because we still have this thing that we have to deal with, so we're going to multiply by 2. That's going to give us what our actual remainder is. We had a to the second. It's going to drop down a power, so it's going to be 1a plus 7. And then we're going to add 10 over 2a minus 7 as our remainder. Okay, so those are the 3 types of dividing that you can do with polynomials, either monomial or long division or synthetic division. I'm sure that there's some other types out there, but these are the 3 that we're going to focus on. So if you have any questions, please bring them with you to class or leave them in the comments, and we'll address them as soon as we can.